Hello everyone, this is Sumerian, and in this video we are going to be talking about programming in the toy box. And I'm not going to be talking about the basic programming. I'll show a little demonstration of the basic programming, but we're going to be talking more about advanced programming in the toy box. A lot of my videos show you exactly hook this up to that and this up to that, but I'd like to take a little time to actually explain the hows and whys in the toy box so you can figure out how to do this kind of stuff yourself a little easier maybe. So first thing we're going to talk about is how programming works in the toy box and how I look at it myself personally. And I look at it as a cause and effect type programming. You need a cause to create an effect. There's a lot of creative toys in the toy box that are cause toys, as I call them. It'd be trigger areas, dynamic triggers, push buttons, action buttons, all sorts of toys. That's definitely not an inclusive list, but there's all sorts of things that are used as cause toys. And then the effects are like fireworks, generators, doors, almost anything you can make happen in the toy box would be what I consider an effect. So we're just going to show a simple cause and effect type thing. Another way to look at it in a programming type language is cause and effect programming is an if-then statement. And everything you program in the toy box is pretty much an if-then statement. For example, if I want to fire off this fireworks generator whenever any player enters this trigger area, I'm basically creating a statement that says if any player enters this trigger area, then shoot off some fireworks. And another way to look at it is when you're programming or when you're making logic connections in the toy box, the first toy that you're connecting is your if statement. So right now my trigger area is my if, and I'm going to select the parameters of the if. I'm going to say if entered player any, and that is my if statement. Now I am allowed to select my then. And so I'm going to select my fireworks, hook it up, and I'm going to say then make a large purple flower. So we've just created a statement that says if any player enters this trigger area, then shoot off a purple flower firework, which we just see there. And it will happen again and again and again. And this is your very, very basic programming in the toy box. This is what every single connection can be viewed as a if-then statement. Now what I want to be showing you how to do in the toy box is the more advanced stuff. And the more advanced stuff are toys that I consider they're not really cause and they're not really effect. There's something in the middle. They're not really either, but at the same time, a lot of them can be both. And the toys we're going to be focusing on are the toys that I use the most to do my advanced programming. And that would be the logic gate, the logic and, time delayers, counters, randomizers, and a few others as well. These are the toys that really let you flex your muscle in the toy box and do stuff a little more differently, so you're not just doing a basic if-then statement to everything. Now the first toy we're going to look at is my all-time favorite. It's the one I talk about the most. I don't even know if there's a video I've ever done that doesn't have one in it. It's the logic gate. And the reason it's the most powerful, or the one I use the most, is because it's the one I consider the most powerful. Because like I said, in the cause and effect programming in the toy box, everything is an if-then statement. But a logic gate is an if-then-else statement. And that doesn't sound like much of a difference, but it is actually a huge difference in programming. If-then-else means you can actually say have multiple effects possible from the same cause. So what we're going to do here is I've got a door here, and I don't know if I've programmed it yet so that it's permanently going to be closed. So I'm going to hook this button up So it's permanently going to be closed. And right there I just said if the action button is pressed, then close the door. Another basic if-then statement. And so I'm now going to walk over here and make sure this door is closed. Yes, this door is not going to open for me. Now, I'm going to program a little something using one single logic gate that is basically going to be if a player approaches this door, then they're going to get a message saying you need a key card to open this door. But if they've collected the key card, which is sitting over here, then when they approach the door, it's just going to open for them. And the way we're going to do that is we're going to use a dynamic trigger hooked up to a locator, which we'll put right in front of this door. Now the thing about a logic gate is it is an if-then-else statement, but it requires a cause to hit it before it will do that if-then-else. So what that means is you have to send that logic gate an input in order to use its powerful if-then-else statement. So in reality, what you actually need with a logic gate is an if-then statement that then triggers the if-then-else. And we'll explain as we go here. We've hooked the locator up. So I'm just going to set this dynamic trigger up so it's using the locator. I'm going to make the trigger distance pretty small so it's just around the door. So I'm going to hit 3. It's a common number I use. It's fairly small. And what I'm going to do is say if any player enters that dynamic trigger area, input. So what we've just said is if any player enters this, then, and then it will trigger the if-then-else statement. So logic gates, when you put them down and when a toy box loads, by default are set to open. They have two states, open or close. But they're default to open. So whenever I program with a logic gate, I usually do the thing that I want to be true by default to the open state. And in this case, the player, when you first load the toy box, the player has not collected this key card. So I want the message, and I think I've programmed it in, you need a key card to open this door. I want that message to be fired if the logic gate is open. So if a logic gate is open and you send it an input, the signal will go out the output. And the way I view this is the if-then-else statement is if open, then output, else input blocked. So if the logic gate is open, then it will send a message to output, else or otherwise it will send it to input blocked. So another important thing about a logic gate is you have to control what opens and closes it. This is how you give it the power to decide what to do. And in this case, since what we want to happen is we want this door to open only if the player has a key card, I can set this up directly on this key card so that if it's broken or collected, then close this logic gate. So only if this is picked up will this logic gate close. And if the logic gate is closed, that means the signal will come out input blocked, and so we want to open the door with that. So what we've just done right now is we've done a statement that says if any player enters this dynamic trigger area, then if the logic gate is open, then display this message, else open the door. So right now we should get a message, you need a key card to open this door. And because we've already set it up so that collecting this key card will close that logic gate, now that I have the key card, that logic gate has closed. So now if I approach the door will open. The statement will have become if open, then display the text, but it's not open, so it will do the else open the door. And there we go, the door is opened. So that is the power of a logic gate. There's a lot more things you can do with them. You can chain them together so you can have a lot more options, and I've done tutorials on chaining logic gates. I'll probably do them again. But a logic gate is incredibly powerful if you remember to view it as an if-then-else statement. Now, another one I'm going to try and talk about right now is the AND gate, or the logic AND. And the logic AND has two main purposes. The one I use it for a lot is I use it as a one-shot trigger, because a logic AND, when it receives an input and it sends out a complete message, which is the only message it can send out, once it sends it out, it will never send it out again unless you send a reset message to it. So I'm going to have Disney Infinity logo in red, fire off if this logic gate is complete, or logic AND is complete. Now, a logic AND is smart. It knows how many different toys you've hooked up as an input to it. So right now I've only hooked up the one, so if I push this one button, the fireworks will go off, but they'll never go off again because it only does one-shot trigger. Now, I'm going to send a reset to it with this button right here. And I'm now also going to hook up this button also as an input. So now, oh, I sent that one as a reset. Let's try that again. If we press the button, input to that logic AND. So now there are two inputs to it, and it knows that. So I'm going to reset it. And now if I push one button, nothing will happen. And I can keep pushing this button forever. It only cares that I pushed it once. What it's waiting for is me to push this second button. And there go the fireworks. So the logic AND allows you to hook up multiple things at the same time. And this is something you can view as an if and then statement. So in this case, it was if button 1 is pressed and button 2 is pressed, then fire off those fireworks. So the logic AND lets you add an AND into your if there, which is kind of handy to have. You can hook up as many things as you want to it. In fact, I can switch it so that this button is not going to be resetting anymore. Now it's going to be inputting to that logic AND, and I already reset it. So now I can hit these two buttons. I can keep hitting one of these buttons. Nothing's going to happen until I hit this last button, and there are fireworks. And at this point, it has become an if button 1 is pressed, and button 2 is pressed, and button 3 is pressed, then fire off those fireworks. So that's another powerful tool we can use in the toy box to really do some advanced programming. It looks like I'm probably running short on time, but I am going to try to continue this series and move on to counters and other things, and also continue on with the what else you can manage to do with a logic gate. But for now, this is Samirian. I hope this has been helpful to you. If you have any questions, as always, feel free to ask, and have yourselves all a wonderful day.